Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is count the substrings. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement and it says that given a string s, the task is to count the number of substrings which contains equal number of lowercase and uppercase letters. One example is given here. Let me explain the example. Okay, so the example says that we have a string and this string is G-E-E-K. Okay, and in this string we have to count the number of substrings which are having equal number of lowercase and uppercase characters. So first of all, let me write all the substrings possible. First one is G, after that G-E, after that I have G-E-E, after that I have G-E-K. Okay, and after that I have E, then E-E, then E-E-K. After that I have E, then EK. After that I have K. Okay, so these are the substrings possible. Now, if you see all these substrings carefully, then you will find that we have three substrings. We have three substrings which are having equal number of uppercase and lowercase characters. Okay, so 3 is going to be the output in this case. Now, I hope you guys got the clear understanding of the problem statement. Let me talk about the solution now. Okay, so when we looked at this problem, then the first approach that comes to our mind is trying out all the possible substrings. Okay, so let me take an example. Str equal to G E E K. I'm going to take the same example as given in the problem statement. Okay, so now first approach that I have is I can I can check all the substrings like as I'm doing here. So I can check all the substring that I have, and in that for every possible substring I'm going to count the number of like uppercase and lowercase character. Okay, so it will be something like for I equals to 0, I smaller than length, let's take n, and I plus plus. Okay, and after that I will start for j equals to I and j is smaller than n and then j plus plus. Okay, inside this loop I will have all the substring from I to j. Okay, so I'm going to traverse the substring again. So I will start one more loop, which is of like k equals to I to k is like equal to j. Okay, and in this loop, I'm going to count the number of like uppercase and lowercase characters. So if character is like is lowercase, then do like I will have a counter which is okay. So I will have a counter here. At this point I will have a counter which is lowercase equal to 0 and uppercase equal to 0. Okay, so whenever I have lowercase character, then I will do lowercase plus plus, else I will do uppercase plus plus. Okay, and now when this particular loop completes, then I will have the number of lowercase and uppercase character for a particular substring. After that I'm simply going to check if my lowercase is double equal to uppercase. In that case I am going to do answer plus plus. So answer is again a counter which is going to store the number of substrings. Okay, so answer equal to 0. When uh, when this whole loop completes, then I will have the number of substrings in the answer variable. After that I'm simply going to return my answer. So return answer. Okay, so if you see this approach carefully, then you will find that it has the time complexity of O of n cube. So we can optimize it. Let me talk about the optimization. If you see this code carefully, so you will find that I'm doing some repetitive task. Like let me okay, so I'm going to take string as G-E-E-K. Okay, let's check for I equals to 0. If I have I equals to 0, then the possible substrings are G, Ge, Gee, and Geek. So first I will check for this substring, that how many lowercase and uppercase character are there. So lowercase equal to 1 and uppercase equal to 0. Fine. After that, for this string I have one lowercase and one uppercase. So I have lowercase equal to 1 and uppercase equal to 1. Fine. After that, here I have lowercase equal to 1 and uppercase equal to 2. Okay, and here I have lowercase equal to 2 and uppercase equal to 2. Fine. The question is, if you know how many lowercase and uppercase character are like till this point, if you know. Okay, so is there any need to check the same thing again in this iteration? But what I'm doing in this loop is I'm going to check the same thing again. But what I can do is, if I know the answer for this, if I know that I have one lowercase character and two uppercase character, so in that case I can simply check only this character. If like from this, see, if I have one lowercase character and two uppercase character till this point, and now I have encountered one more lowercase character, so I'm simply going to do lowercase plus plus, which will give me lowercase equal to 2 and uppercase equal to 2. Fine. I hope it's clear to you. So in this code, what modifications I can do is, okay, I'm going to write the same code again, but with like optimization. So I'll start for I equals to 0 and I smaller than n, and then I have I plus plus. After that, I will have one more loop, which is j equals to 0, j equals to I, j is smaller than n, and j plus plus. Now inside that loop, I am going to check, like inside this loop I will have all the substrings like g, ge, gee. So for that I'm just going to first of all I will have a variable which is lowercase equal to 0 and uppercase equal to 0. Okay, after that I will check here if current character, like if ch double is lowercase. Okay, in that case I will do l plus plus, else I will do upper plus plus. Okay, fine. And after that I will do one more thing, which is if my lowercase is double equal to uppercase, then I can do answer plus plus. I hope it's clear to you. So after that, at last you will simply return the answer, return answer. Initially you have answer equal to 0. So now you can see that this approach is running in O of n square times. So this is the optimal answer, and if you like submit this problem, if you submit this solution on Geeks for Geeks, then it is going to be accepted. Okay, fine. But what I'm interested in is explaining you one more approach, which is the most optimal approach. Optimal approach. This approach is very interesting. First of all, let me write a string. This string can be like, okay, HELLO, hello world. Okay, now in this string I have some uppercase character and some lowercase character. I want you to do something here. What I want is, I want you to replace every lowercase character with -1 and every uppercase character with lowercase character with -1, uppercase character with 1. Okay, you can do the vice versa as well, like you can do uppercase as -1 and lowercase as 1. Okay, fine. So if I do so, then I will have -1, 1, 1, -1, -1 again. I will have here 1, after that -1, after that 1, 1, and -1. Okay, so this is the array that we got. Now in this array, I want you to notice one thing, and it is really very interesting. And that thing is, if you mark any sub array which is having some 0, then that sub array will surely have equal number of uppercase and lowercase character. Why? Because you are replacing every uppercase character with 1. So like if I have these two characters, these are 1, and after that lowercase character -1, so obviously sum is going to be 0 here when I have equal lowercase and uppercase character. So now this problem becomes a simple problem where I have to find, like, count the zero sum subarrays. Zero sum, quite simple, right? So now in this problem I can simply count the zero sum subarrays. Okay, fine. Now the question you are going to ask me is, hey, how can we count the number of zero sum subarray in the array? Okay, so first of all let me move that array. Okay, so I'm going to take this array here. Okay, fine. Now first of all let me write the question. Question is, how to count the number of zero sum. Okay, so this is a standard DSA problem which is asked by various companies in the interview process. Okay, so even you can find this problem on Geeks for Geeks if you search this problem. Okay, so now let me explain you. First of all, Just don't ask why I'm doing this. I want you to do one thing, and that thing is to write. Okay, so I have done one wrong thing here, that I have written using black color on the black page itself. Okay, fine. So now I hope it's visible to you. What I'm going to do is I'm going to write a prefix sum sub array for this. Prefix sum array for this. Okay, so first of all I have -1. Then I have sum as 0. After that I have sum as 1. After that I have sum as 0 again. After that I have sum as -1, then 0, then -1, then 0, then 1, then 0. Okay, let me recheck it. I have -1, then 0, then 1, then I have 0 again, then I have -1. After that I have -1 plus 1, which is equal to 0. After that I have, okay, -1, then I have 0 again, then I have -1, and then I have 0. Okay, so I don't think this example is like good. So let me change the example. I'm going to change the array in order to give you a better explanation. So let's forget about this array and take another array so that intuition will be more clear to you. Okay, so I'm going to take a array. So array is going to have values like, 1 1 1 -1. After that I have 1 -1 -1 -1 -1 and 1 -1 1. Okay, and then -1. Okay, so now again write the like prefix sum sub array for this. First of all I have 1, then I have 2, then I have 3, then I have 2, then I have 3 again, then I have like 2 1 and 0. Okay, and then I have -1, then I have 0 again, then I have -1 and 0 again, then I have -1. Okay, fine. Now for this sub array, for this sub array, okay, for this sub array I want you to notice one thing, that whenever I have repeating sum, like here you can see I have 2 and after that I have 2 again. Okay, this is the first, and after that you can see that I have 3 and then I have 3 again. This is the second, and after that here you can see that initially if I take 0, then I have 0 here and then I have 0 again. Okay, fine. Now this point is very important. The like the one which I have marked. Okay, so if you see this sub array, so like this sub array, which is this one, so you can see that I have a zero sum sub array. Why? Because I know one thing, that x is any number plus 0 is always equal to x. Okay, so can I write that if I have like some x till now, till this point, so and then I again see some x, so I will have like zero sum somewhere in the middle, because this is what I have written here. I have some x till now and then I'm doing some 0 and then I'm again getting some x. Okay, so this is what I have written. Now I hope you are building the intuition from this. We can build the intuition. We can say that whenever we have repeating sum, like if I have sum as like s at any point and then I have some sub array, and adding this sum to sub array, I am again getting this sum s again. So I am sure that at this point I will have zero sum sub array. Okay. So now I can do the same thing. What I can do is I can calculate prefix sum. So first step is calculate prefix sum, prefix sum. And when we calculate prefix sum, then we are going to check if this sum like we have seen this sum before. So how to check whether we have seen this sum before or not? We are going to use map to store the sum. Okay, so I will say, okay, so if my map dot contains sum, like I have seen the same sum before, so I can surely say that I will have like zero sum somewhere in the middle, because I have sum here and then again I have sum here. This is what I'm checking. Okay, so whenever I have such condition, then I will count how many times I have seen that sum. Like you can see that if I'm at this point, so I have seen like 1 2, so I have seen 2 times the same sum. So what I can do is, the thing that I know is these many times I will have the sub array. Like if I have s, then I have plus 0, then I have plus like s again, then I have plus 0, then I have s. So for this sum I can have one sub array like this, and after that I can have one sub array like this. So like how many times I have seen that sum, that many times I am going to increment my answer. Okay, so I will do something like answer plus equals to map dot get I. Now what is map dot get I? Map is storing the count of like how many times we have seen the sum. So sum with frequency, this is what I'm storing. Okay, fine. And After that I'm simply going to add, like this sum, the current sum that I have to map. Okay, so map dot put sum. Okay, and after that I will have like the already sum that I have, which is map dot get sum plus 1. This is how we add a value to the map, right? I hope it's clear to you. Now this is how we calculate the zero sum sub array in any uh, array, in any given array. How many zero sum sub array that, which we have, we do this process to check. Okay, now I'm going to show you the code. Okay, so let me show you the code. Okay, so this was the code for the approach that I have explained you, but I'm not going to show you. I'm going to show you the optimal approach. Okay, so on the left hand side I have Java code, and on the right hand side I have C++ code. Now you can see that first of all I'm creating a map. After that I'm adding a value 0 initially to the map, which says that okay, I have 0 sum one times. Okay, fine. After that, for all character, first of all the thing that I'm doing is like -1 and one thing, which I have explained you, like if character is uppercase then 1 and else it is -1. Okay, after that this is the point where I'm calculating the prefix sum, so it is prefix sum. After that I'm checking whether I have seen the same prefix sum before or not. If I have seen, then I am doing the same that I have explained you. Okay, and at last I'm just adding the value to the map. Okay, fine. The same thing I'm doing here as well. Okay, if you talk about the time complexity of this, so O of n is going to be the time complexity, and space complexity is again O of n because I'm using a map. So this is all about this problem. I hope it's clear to you. Thank you.